All right. Yeah, so we'll go ahead and get started. First thing is that if you have questions anytime, please interrupt me. We have a relatively small group, and so you are definitely welcome to unmute yourself and just ask me and interrupt. Or if you put it in the chat, I'll try to keep that up. But again, lots going on my screen. Also, I'm going to do a survey at the end. I know some people wanted a certificate of attendance, so they can get some PD hours. If you fill out that survey at the end, then that'll help me put that together for you. A little bit of background we'll start with. So I taught for 13 years in Memphis, what was originally called Memphis City Schools, then the name changed. But anyways, I taught in a very diverse school and taught students often in the same class that were on tons of different levels, but they tended to be students who were often far behind in math and reading. I know a number of students came to me one year and they just hadn't even had a math teacher the year before. It was just a rotation of subs. So it really challenged me to think about how I taught. These are some of my students, but they didn't always look this happy, especially like my first year. But I figured out some strategies that worked really well for them and really transformed my classroom. And I love sharing those with people. Yeah, because I was trying to teach something like this to my students who often, again, were behind in math and reading, and that didn't work great. So my biggest thing is that I titled this so I use the word engagement in the title, but for me, like engagement is not so much about like doing experiments and blowing things up. I found that students, the thing that engages them the most is when they feel like they can be successful. So these are the strategies that really helped me make my students feel like they could be successful. So yeah, we'll go through these and then at the end definitely have lots of time for questions, but please do ask questions kind of as we go if they come to you again in the chat, or even just unmute yourself and interrupt if we have a small group. Some of you know me through positive physics, some of you don't. I'm happy to give a quick tour of positive physics at the end. That's totally optional, and these strategies should help you whether or not you use positive physics. So yeah, if we go again back to that problem that I showed before. So I was trying to teach this to a lot of students who really struggled with math. And sometimes I thought that my problems in my classroom were like, I had a lot of behavior problems in part because I was 22 when I started teaching and had some students who were 19 or 20. But really the problem was that my students didn't know how to do what I was asking them to do. So I would do a problem like this, or two problems like this, or three problems like this in front of them, and then give them a similar problem. And then they didn't know how to start, and it was frustrating for me. I was like, maybe they weren't paying attention, but really it's like they didn't get enough kind of chances to even just start the problem, and they had seen me do it like 20 minutes ago, and so how did I expect them to actually know how to start a problem? So I started, instead of thinking of this as like one problem, I started really breaking it down into bite-sized pieces. So when I see a question like this, which I ended up doing with students who were pretty low in math, and they could, a lot of them could get to a point where they could do it or at least get really close. So I thought about this as individual skills. So first, drawing free body diagrams. Second, trigonometry. Third, analyzing free body diagrams. And fourth, putting it all together. And instead of trying to, and I know we still have just some people hopping on right now. So our first strategy that I was talking about that really helped transform my class was to think of, whenever I saw kind of a complex physics topic, really break it down into bite-sized pieces and really try to isolate those pieces. So instead of like trying to start a unit by teaching like a long question like this, I love to give my students really quick practice, and they could really get down the skills of kind of each one of these. So instead of a problem that looked like this, I would give my students like tons of questions, or like one full day where all we're doing is practice drawing free body diagrams. Especially, and this is even a separate unit. This was like my third forces unit. So this is we're just walking through an example of, this unit is forces on an incline. And so even though they've already known how to draw forces, we thought it was worth spending a full day just allowing students to practice drawing the forces when an object is on an incline. Because if you've taught physics before, you know that in these cases, students always want to rotate the weight, but it really needs to be straight down. the normal force stays perpendicular to the surface, and things like that. So even my lower level students could really build confidence on just drawing a really good free body diagram, which was critical later in this unit. The next day, then we would only practice trigonometry. So not even worry about drawing the rest of the forces on there, but just practice trigonometry, making sure like we varied like the unknowns that were given from, oops, my bad. There we are. Varying the unknowns they were given so they could do trigonometry back and forth. And I'll even show you a little tip later that even with my lower, almost conceptual level physics students, they got to be really good at doing trigonometry because we really just isolated that skill. And then finally, this was our third skill. This was really a breakthrough for me, is I had a lot of students who would struggle with finding net force, or much even harder, finding an unknown force. And I realized that I could give them questions. I want them to get lots of just like quick back to back to back practice with this. So I could give them questions with the trig already done for them, with the free body diagram already done for them. So they could knock these out. Like they could do one of these per minute and get 30 chances where they just really get a good idea of what does net force mean, what does the normal force balance, or even kind of reversing it and doing it backwards, giving them the net force and giving them a description of the speed. And I like them to do it this way really conceptually, as opposed to just relying on a formula, especially if they weren't very confident in their math skills. And then finally, the fourth skill was just putting it all back together. And it was really cool to see that sometimes, especially my higher level students, when they got each of those individual skills, I wouldn't even have to teach them this fourth skill of putting it all together. They would just go ahead and start doing these problems early. So that was honestly like the biggest game changer in my class, was learning how to really break down these skills into bite-sized pieces. And even if there's a skill that involves, like this last one involved me doing part of the problem for them so it could really isolate that skill, giving them tons of quick and consecutive practice on that was really huge in boosting student confidence. And then the last thing I'll say about this building block method is, not only did I decide to start teaching it this way, but eventually I realized I should actually assess it this way as well. So on the assessment, I would give students questions where all they had to do was draw a free body diagram, or all they had to do was trig, or all they had to do was analyze a free body diagram, in addition to a question where they would have to put all of it together. But the reason for that is some of my lower level students, they might not get to the point where they could put everything together or even do the first step in a problem, but they'd like to be able to show, and I could give them points for it, that they could do the other steps in the problem. Like if a student couldn't do the free body diagram drawing, if I didn't do this, they couldn't prove to me that they knew how to do the trigonometry. So not only like teaching this way, but also assessing students this way, I found to be really valuable. And in addition, it a lot of times gave me a lot of good feedback about like where students were getting stuck if they couldn't do the whole problem, because they could show each of those skills. And yeah, again, if you have any questions, please do feel free to unmute yourself and ask. But
Jack, I
yes.
have a question. Using positive physics, I'm just wondering how you manage the hand drawing of like the free body diagrams.
Yeah. So I would have them. I don't know if you've used and sorry for people who don't use positive physics as a positive physics specific question, but I'm happy to answer it. Happy to answer it now. So yeah, I did some whiteboarding, and I'd still require students to turn in. So on positive physics, you know that like they would do like they identify the directions of the forces when they're doing that free body diagram drawing practice. Sometimes I would actually include, I don't know if you use the print problems feature, but I would include sometimes the free body diagram drawing in what I printed out. And so then not only requiring them to answer those questions, but also requiring them to draw it. I also like to do a lot of problems on the board where like I would make a subtle mistake in drawing the free body diagram, and students love to correct your mistakes. So yeah,
Thank you.
sure. Yeah, anything else before I move on to the next strategy? All right, so cool. The next one is probably some people love this, some people don't, and that's fine. And especially your math teachers might not. But I found with my lower level physics students that I started giving them every equation we were going to use pre-manipulated. And when I send an email out, or actually, maybe I can do this right now. Oh, that's not letting me copy it. Yeah, I'll send this out later, but whether or not you actually use positive physics, I have a list of all the equations in their original form and manipulated forms. So I'll send a link to that out in the email when I also send out this recording. But I found that a lot of my students struggled with even manipulating a three variable equation. And I didn't want them to feel like that my class was another math class. That's the worst thing, is when a student would tell me, this is physics is just another math class. But by giving them these pre-manipulated equations, like it really let students focus on the physics. And I knew like some of them would having a hard enough time in their math class, and I didn't want them to feel like they didn't have a chance to be successful in physics. So yeah, this one was really huge for me with my lower level students who struggled with math, and also was I mentioned earlier that I originally didn't even try to teach them trigonometry, but by giving them this, like trig actually became what students thought of as kind of like the easy part of the problem. And again, yeah, I'll send this link out by email. Yeah, and this is what it looks like. So you could give students this link, and they can have it also has the definitions and units of everything. So just yeah, I'll send that to your way a little later today. You'll notice that as I went through on the left-hand side, I think sometimes we realize that like our students are pretty low in math, but we don't remember that they're also pretty low in reading. And so I just try to use as simple notation as possible. And so like in this example on the left, which is like it's using all of these kind of this extra notation, and just I'd be mindful of trying to make it as simple as possible. In addition to that, trying to use real world examples whenever possible. I know that to a student looking at this, like it may not be obvious that we're referring to a block on a hill, but if we on the right hand side, it's a lot easier to understand kind of what's part of the math and then what's part of just like the drawing itself. All right, and then on assessments. So I really like, for people who know positive physics, you know it operates this way, but I'm a big fan of making my assessments really similar to the homework or class work. So actually on positive physics, it literally randomly pulls questions from their homework to put onto an assessment. So just making sure like students aren't surprised by what they're seeing. But so I would use, and even before positive physics, I would use almost the exact same problems that I use from a homework or classwork, but just changing the numbers so they couldn't just remember the answers. Once again, probably like one of the biggest things for me was just actually testing those isolated skills, because to allow students to earn points for the things that they know and get some things absolutely right. And then one other thing that I really like to do is I let my students decide if they wanted to use their notes on their test. But my deal was if you use your notes on the test, then I capped your grade at 80 or 85%. And so what this did, I can make that available to everyone. But my higher level students would just choose that they weren't going to use their notes because they didn't want to have their grade capped at 85%. But my lower level students, they might start off the year using their notes until they gain more confidence and then didn't need to use them in the future. All right. And then I know a lot of people use the guess method, and this is similar to that, but slightly different, is I really like to list out, like just have students know that whenever they see, in this case, like a one-dimensional motion problem, to list out the 5 or 6 things that they're going to need for that entire problem, and then start filling in the given. It's a really good way for students to know. My students would I'd have it drilled in their head that for a one-dimensional motion problem, they needed 3 given. And so looking at this, they're like, okay, I know 2 of those numbers are going to be given, filling out that those are the final speed and the time, and then also knowing like there's a key word here, rest, or looking at the diagram and seeing that object's initially at rest tells me my last given is the initial velocity. But just I found that having a student, sometimes students really freeze up on just getting started with a problem and just having them know, like, okay, the first thing I can do is just kind of list all the variables that I'm going to need in this problem and almost having those memorized because we do so many motion problems, especially at the start of the year. But you can use that for momentum. I like to just list PMV underneath each object that's moving. It's a little bit trickier for energy, where I first have students identify what type of energy is present at each time, and then underneath that, just list the things that they see in the equation. But I really found that starting with a list is really valuable for students to making sure they're identifying the given and going from there. I find it a little easier than like kind of listing the guess method if you're familiar with that. And then I'm happy to talk more about this later. I also with my lower level students, instead of using like the more complex motion equations, I only use scalar, so they didn't have to worry about negatives, and they would always calculate the average speed in any defined distance. And this again just made it a lot easier for students who struggled with math. I'm happy to answer more questions about this later if you'd like. Some people love like the other way, and I do understand the other way sets up students better who are going to go on and take physics in college. But if they're not, this is like a really positive way for them to be able to like do the motion problems without getting as hung up on the vocabulary and negative signs. All right, and then also have a question for you. I'm gonna make you do a little bit of physics. So I also have a specific way that I really like circuits. It made circuits go from one of my least favorite things to teach to maybe my favorite. And so my just question for you, put in the chat if you don't mind, how much current will flow through resistor A? I'll give you like 30 more seconds if you want to answer. All right. So, the fact that I didn't get a ton of answers, it makes me wonder if I had some people calculating equivalent resistance first. And so I like to teach circuits first without having to do that. And so I use something called the routes method. And so first I just trace the route that A will be on. And then this works for like 90% of routes. You just have to tell students if there is a circuit that doesn't have distinct routes, then we actually do need to use equivalent resistance. But sometimes like we overcomplicate things. And I remember originally I was always having students find equivalent resistance, and it just made circuits so mathematical and less conceptual. So in this case, we have 20 volts to push electrons through this route on which there's 10 ohms. So 20 volts over 10 ohms would give us 2 amps. And then they could separately calculate the current going through here, which would just be 20 divided by 8 or 2.5 amps. But then we can solve the whole circuit just by applying Ohm's law to the route separately. And 95%, maybe more, of practical circuits include distinct routes like this. So we don't really need to worry about equivalent resistance. And so I teach it like this first. It's super conceptual. It also emphasizes that less current is going to flow along routes with higher resistance. And it's just a really good way to make circuits conceptual and pretty easy to easy to do. So I do those two kind of weird things with motion as well as circuits that makes things pretty nice for my students. But yeah, I think the biggest two going back are really those breaking things down into bite-sized pieces and then assessing those pieces individually, as well as then providing the manipulated reference sheet to students who need it. I was teaching in Tennessee where there wasn't a state test, so I do understand that for some teachers, like that might not be something you want to get your students in the habit of if they don't have a reference sheet on their test. Although I feel like most states do, but it just might not have the manipulated one. But yeah, let me go ahead and pause right there and see if anyone has any questions. And in the meantime, let me go ahead and grab the link to the survey so I can put it in the chat. And I'd really love to hear your feedback, as well as if and then this will also enable me to send you a certificate of attendance if you need that. Oh, one quick thing: if you do fill out this form, I'm gonna use mail merge to like create everyone's certificates. I have a bunch to send from earlier today. It will add you to the Positive Physics mailing list. So if you don't want to be on that after you get your certificate, feel free to unsubscribe. But yeah, I would love to hear your questions. I'm also happy to. I wanted to show if people were interested. I'm happy to give a quick tour of Positive Physics. I know some of you use it already. But yeah, happy to take questions first. So Amy said, did you create different level calculations for your different students? So I I just require, like, if I had, especially if I had students with IEPs, like I might not require like the last thing where they put it all together. And so I would just require them to answer just answer those individual skill questions. So also breaking it down by skill really makes it easy to differentiate tests. I can show you a little bit on for my last 5 years in the classroom, I was pretty much exclusively using Positive Physics, which is started as a classroom website for my students. I'll show you how to differentiate on there. Remind me if I don't get to that. Megan said, for your grade cap, does everybody who used notes and got above 80 or 85 just get 80 or 85, or is it prorated? So I didn't make it prorated. I had it just be like, if you got above the cap, so if the grade cap was 85 and you got a 92, then you just went down to get the 85, because that made students more likely to use it, because if they scored lower, if they were going to score lower than an 85 anyways, they would just use it and they didn't feel like that was like hurting their grade. I had students were a lot more hesitant to use it if they were going to like see an 80 or see like a 78 on their quiz, like even get lowered further. So when mine was capped, it was just like, hey, if you got below the cap, you just got your score. If you got above the cap, then you just got your cap. Yeah. Sandy said, how do you incorporate lectures and labs into your work? Yeah, so let me pull up Positive Physics real quick. And so yeah, this is and again, if you need to take off and don't want to look at this, totally understand. But and yeah, I was not trying to be like a sales pitch. I just want to show you what I did in my class. Lots of this stuff on Positive Physics is free, and if your school can't pay for it, if you want to use it and your school can't pay for it, just let me know, and we do pay what you can pricing for any teacher whose school won't pay for it. But yeah, sorry, I have to kind of blend these ones together. So how to incorporate lectures and labs. So I would basically teach one or two of those skills that I showed before every day. And then that meant every unit for me lasted about a week and a half to 2 weeks. I always started my units with an inquiry activity, and I built all those on Positive Physics. A lot of times it refers to a PhET simulation where students are just experimenting to figure things out. And then at the end of my unit, it's not on this website, but I would do a lab where I would basically take like a complete problem and like set it up, and then just have students like predict something. Usually it was, oh, how much time will it take for this object to get down the ramp? Or when we get forces, I would create like have a cup with an unknown weight inside it and have a setup where they could experimentally determine how much, like what was in that cup. So I'd always do a kind of an investigation at the start of the unit, and then more like I call them engineering labs at the end of the unit. I would usually spend about the first 15 minutes, 15 to 20 minutes of class, like practice, like working together on the board. And then I'd turn my students loose on, had the advantage to have of having this website. So I could get them to practicing on their own pretty quick because the website would tell them if they were practicing correctly or not. Cool. Any other questions before I show you around positive physics? And again, please make sure you fill out that survey if just at any time within the next half hour or so if you want me to send you a certificate of attendance. Beth said, do you use this more often in class or as homework? So I didn't love to enter a lot of grades because I wanted to spend more time like actually doing things that like interacting with students. So I would basically just say, hey, this whole unit is due next Friday or something like that. And just say, we're going to have class time to work on it. Whatever you don't finish during class becomes your homework. This is like, I highly recommend doing I would recommend to them like, hey, if we just covered free body diagram drawing, I would recommend doing these two skills and not saving it all for the end. But I didn't enforce that because I just wanted to enter one grade at the end. Yeah. Let me go ahead and show you the website a little bit. And so yeah, it really takes kind of the things that I talked about and like sets it up. So this is our introduction to forces unit. So our first skill on that was drawing free body diagrams. So it gives students a ton of practice just identifying the forces. Every lesson came with a video. Um, I usually use it to back up my teaching. I know lots of teachers use this now. Some use the flipped classroom approach, but basically just giving students lots of chances to just identify like, okay, weight always acts down. Normal force depends on if it's touching a surface and acts opposite of the surface. And so they could just get tons of practice getting super comfortable with drawing free body diagrams. Then that was just like the first three forces. Then this was adding more forces. Oh, I should have added this as a strategy. I think one other thing is just making sure we're super clear about what we mean by forces. So just having really clear definitions of what forces are. I'll send a link to how I define forces as well. And then this was a skill I showed as well as the free body diagram analysis. So having like now these problems, they have the forces drawn for you, and all you're trying to do is figure out the net force and whether the speed is increasing, decreasing, or constant. I should mention, I always forget to say that on positive physics, all the numbers are randomized. Um, Sandy said that they really like my force definitions and the diagrams. Thank you. um, So as students practice on positive physics, they can click check answers or enter at any time. Right answers turn green. Wrong answers, there's a little X appears, and but they can be fixed. The site keeps track of students' completion score as well as their accuracy score. So accuracy score only goes up if a student gets it right on the first try. And then the completion score goes up. Doesn't matter how many attempts. I strongly recommend grading students on their homework on completion only and telling them that the accuracy is just feedback for them about what they need to study. So if they have a low accuracy score, that's fine on the homework, but it's something you need to study before on the test. Um, but it's cool to see that other people do it differently. So I know Adam, hey Adam, uh, has used the site a lot, and he said use either percentage for completion or accuracy to assign a grade. Um, I guess depending on the assignment. Uh, Demian said, "Are we able to use more complicated notation as a differentiation tool?" Yeah, so on unfortunately not yet on our forces. We actually do have a setting in teacher settings. So you can use, for motion, we have it where you can use scalar or vector notation. That's something we've always had like on our list about using. I like to use n for normal force. I know people like to use f sub n. We don't have that yet, but there is a possibility that that could come in the future. You can also decide if you want to use g as 10 or 9.8. And it's really built to be super friendly. So if a student we have every answer has a 2.5% tolerance. So if they're off by a tiny bit or they round a little bit off, it's funny. Chemistry teachers want them to be so precise, but I feel like we're a little bit more laid back. And so as long as they're within 2.5%, we mark it correct. Yeah, and so it really just the site takes you through how to like uses those building blocks to build students up to more traditional complete problems. And these ones at the bottom are really for honors or AP level students. But everything's super randomized, and it's really cool to see students working together, but realizing they need to explain how to do things instead of just giving answers to each other. And then we have an extra practice mode that students can just get more of these problems just to study, as well as an assessment. And how the assessment works is it randomly pulls questions from the homework. So I mentioned that earlier. So on this assessment, it's going to pull 3 questions from the embedded math, 3 questions from this free body diagram drawing skill, etc. And let me tap restart on this because I was showing it earlier. So on the assessment, again, they'll just get a representative sample from each of those skills that they went over. And then on this one, just like Sandy, I would grade this on accuracy. So if they got something wrong, slightly different on the assessment that it locks until they're done with the whole test. Then they can click finalize and start making corrections. And then once again, you'll notice that they'll start getting 2 separate skills. So their original score was locked in, but their correction score will start to increase. Are the assessments and practice problems able to be printed on paper? Yeah. So right there is a. I'm not gonna show it right now because it sometimes if I'm on Zoom and it takes memory, but there is a teacher print problems, and so it prints out a PDF of the problems for students. Right now, it puts a blank anywhere there'd be a randomized number, so students fill those in with their own. We're also actually we're working on something earlier today where you can print it out with the actual numbers in it, um, and then print out an answer key as well. One other thing I want to show people, this is actually relatively new. Hold on, let me get Beth's question first. When doing assessments, do all students get the same randomized numbers? No, the numbers would be different for every student. So, oh yeah, I should tell you, I want to go over like what's free. So the first 5 units are free. You can also like if you want to go in and like take screenshots of stuff, you can do that. You have my permission. I want this to help as many people as possible, so go for it. I don't mind at all. One other thing that's free is creating your own questions for students. So if you go to create questions, there's a little there's a video and some things here. And basically using your own questions with your own students is going to be free, and it is free and is going to stay free. If you want to use our questions, there is a subscription cost. I wish Bill Gates would fund this so I could just give it for free for everyone, but right now we have bills to pay, so unfortunately I can't do that. But yeah, you can create your own questions with randomized values, just like this, and you can organize them into our system as well if that would be helpful. But yeah, I would again, if you have any questions about the about positive physics or about kind of the strategy shared in general, would love to. I'll pause and see if anyone has any questions. All right. Well, if not, thank you so much for. Or
Jack,
yeah.
I can I for the creating the questions, is it all within like if I like can I add to the vocabulary unit this vocabulary section, can I add questions to that? Or how does it all kind of fit in? Do I need to create a new unit or a new
Yes.
course?
Yeah, so right now you create, like, we're keeping our stuff separate, so you create a new course and then create your own. But you can always, if you don't want students to have to like click around too much, you can
Uh-huh.
always just give them like the every problem actually has a unique link to it. So if you wanted them to land straight on this problem, just copy that URL, and then you could share that URL with them and it'll take them exactly there. You can, right now it's a bit tedious, but you can copy, if you have a subscription, you can copy our problems into your own course, but right now it has to be done a problem by problem. Eventually we're going to make it easier to like mass copy our stuff over. But right now, yeah, you have to, those two things are kind of separate. Honestly, it's just because if we let you modify our course, it would make calculating the scores so complicated that I don't want to take that on right now.
Okay, thank you so much. It's been great to hear you, and you're inspiring. So thank you.
Oh, thank you. I appreciate that.
Some people are at the front.
Okay, I gotta go.
Sure.
Bye.
All right. Yeah, well, everyone, thank you so much. I will shoot everyone an email with the link to some of these resources, a recording of this, and yeah, that's about it. I'll hang on for just a second, but please take off, and then if anybody does think of any last minute questions, please ask them. But yeah, thanks again for coming. I can tell your students are lucky to have you if you're willing to join a PD for an hour in at the start of your summer break. So thanks again, and yeah, reach out anytime. You have my email address. I'm here to help whether you use positive physics or not.